Now for Imagine It, we're just learning more every week about the chief scientist, Carl Nelson. He was a magician as a kid, he just said. That reminds me of...
Who isn't a magician as a kid?
Well, that's true,
right?
But the Eli, Magic with Eli guy, he's getting some national fame there.
That's true. That's true.
Yeah, great. Let's get to the science.
Okay, so we're going to do a classic demonstration. This thing has been done for over 2,000 years. Okay, and so you've probably seen it in a science classroom or maybe as a bar trick. It's the classic glass over the candle deal. Okay?
Sure.
What's fascinating about this, though, is that even today there persists incorrect explanations about the science behind this, whether it's in printed textbooks, on the internet, which you might believe, or even in teacher professional development materials. Okay, so we're going to try this. So I got some water with food coloring in it. Go ahead and pour that into our tray.
Sure.
This is certainly something you can do at home. Get a little candle lit here.
Put the whole thing.
Yeah, pour the whole thing right in there.
And it's
carefully.
green.
It's green, and it's just green so we can see it better on the camera. So the experiment is to put the glass over the candle, and then you, Tony, are going to be our eyes and ears to describe what's happening.
Okay.
And then we'll talk about the science. Now, it's going to be hard to see in this little glass like that, so I brought a slightly bigger container with me today. So we're going to use this.
Just a handy-dandy giant beaker.
Okay, a big old flask here. Now, it happens relatively quickly, so you need to watch closely and describe what happens. As soon as I lower this down over the candle, you just start talking about what you start to see in here.
Right now we have a hot air balloon scenario with a giant glass bulb, and we're going all the way down, sealing it in. There's some bubbling at the bottom.
Bubbling happening,
yeah.
Okay.
The flame's still flickering. Fall. It's bubbling still, rocking back and forth. But yeah, as I see...
You can see these bubbles coming up. Those are important.
The bubbles are going.
Okay, candle's still burning.
Candle's going. Okay, there. The water's starting to rise. You can see it inching upward, going up toward the flame. Okay, and now the candle's floating.
The candle's floating?
Well, I didn't anticipate that. And the candle's slightly dimmer. Now see, that's what I thought where we were going with the oxygen burning off.
Okay, excellent.
But now it's rising all the way up. Wow, how about that? And a big sucking sound.
A big sucking sound, exactly.
All right, okay, and lots of bubbling, yeah.
And the candle is still burning there, and eventually, if we wait a little bit longer here, the candle should do, what do you think?
Well, I would think it would extinguish, but...
And why do you think it would do that?
Well, yeah, I guess based on no oxygen, or it's going to hit the water, one of the two.
Okay, so we got this water that's been pulled up inside the container. Now the explanation that's incorrect that you hear all the time is, and I was trying to lead you that way, unfortunately, was that the candle burns up the oxygen and that reduces the amount of gas inside, and so therefore the water gets sucked up inside. Right. Totally incorrect. If you work out the chemistry of how that works with the combustion reaction, you can't, it doesn't really use up much of what's actually inside. It replaces the oxygen with carbon dioxide gas or carbon monoxide and some water vapor. What's really happening is when I held that container over the flame, I heated up the air inside. Hot air takes up more space. Those bubbles you saw coming out were critical because that was air escaping from the container. So we had a partial vacuum created inside there as the air cooled.
Gotcha.
Okay? And that's what allowed the atmospheric pressure to push the water up inside the container. Right. But it's interesting that even as early as, or as late as 2005, incorrect explanations still persist that it's the oxygen that's burning up. Totally not what's happening.
But it's really
air pressure.
There's not enough air, period, in there.
Oh, well, no, actually the air expanded. The air expanded, and
there's too much air.
Well,
is that what I'm going?
Well, the air expanded, and some of those bubbles came out. Air pressure pushed it up inside, and as that air contracted, the water was pushed inside the jar.
I need to go back to school. Carl Nelson, thanks very much for joining us. You can go down to the Imagination Station and see this one, and don't try this at home unless you live in Carl Nelson's house. The hours are on your screen. Thanks so much for joining us. Let's take it over to sports.